Module 6, Macroeconomic Measures, GDP, and Economic Growth. Macroeconomics focuses on the economy as a whole, or whole economies as they interact. Macroeconomic externality occurs when what happens at the macro level is different from and inferior to what happens at the micro level. The economy as a whole is massive. Economic indicators, statistics that measure one or more aspects of the macroeconomic. Measures of aggregate production like GDP, measures of employment and unemployment, and measures of inflation like the percent change in the consumer price index. Misery index, the sum of inflation and unemployment rates as a measure of how bad, i.e. how miserable the economy is. Goals. In thinking about the overall health of the macroeconomy, it is useful to consider three primary goals: economic growth, full employment or low unemployment, and stable prices, or low inflation. Economic growth ultimately determines the prevailing standard of living in a country. Unemployment, as measured by the unemployment rate, is the percentage of people in the labor force who do not have a job. Inflation is a sustained increase in the overall level of prices. Policy tools. National governments have two sets of tools for influencing the macroeconomy: monetary policy, which involves managing the interest rates and the availability of credit; fiscal policy, which involves changes in government spending, purchases, and taxes. What is gross domestic product? The value of the output of all goods and services produced within a country in a year. The measurement of GDP involves counting up the production of millions of different goods and services: smartphones, cars, music downloads, computers, steel, bananas, college education, and all other new goods and services produced in the current year, and summing them into a total dollar value. Take the quantity of everything produced, multiply it by the price at which each product sold, and add it up. In 2016, U.S. GDP totaled $18.6 trillion, the largest GDP in the world. Today, it's more like $20 trillion, still the largest in the world. Final goods and services. Goods or services produced at the furthest stage of their production at the end of a year. That is, they have either been sold to consumers or they are an intermediate good or raw materials that have not yet been used to produce final goods. What's counted in GDP? Final goods and services. Intermediate goods that have not yet been used in final goods and services. Raw materials that have been produced but not yet used in the production of intermediate goods or final goods. What is not included in GDP? Intermediate goods that have been turned into final goods and services, used goods, transfer payments, non-market activities, illegal goods and services. Calculating GDP. If we know that GDP is the measurement of everything that's produced, we should also ask the question, who buys all of this production? This demand can be divided into four main parts: consumer expenditure, consumption; investment expenditure; government expenditure on goods and services; net export expenditure. And here's what the components of U.S. GDP looks like. You can see there's a table. The biggest part of the pie is consumption, and that's about always the case. It's over 2/3 is consumption. Calculating GDP vocabulary. Durable good, a good that lasts 3 years or more, such as a car or refrigerator. Inventory, goods that have been produced but not yet sold. National income includes all income earned, wages, profits, rent, and profit income. Non-durable goods, a good that lasts less than 3 years, such as food or clothing. Service, product which is intangible, in contrast to goods, such as entertainment, healthcare, or education. Structure, buildings used as a residence, factory, office building, retail store, or for other purposes. Trade balance, gap between exports and imports. Trade deficit exists when a nation's imports exceed its exports and is calculated as imports minus exports. Trade surplus exists when a nation's exports exceed its imports and is calculated as exports minus imports. Gross national product, GNP, includes what is produced domestically and what is produced by domestic labor and businesses abroad in a year. Includes only what is produced within a country's border. Adds what is produced by domestic business and labor abroad. Subtracts out any payments sent home to other countries by foreign labor and businesses located in the U.S. Net national product, GDP minus depreciation. Depreciation, the process by which capital ages and loses value. National income, all income to businesses and individuals. Personal income, income made by individuals. Net national product is calculated by taking GNP and then subtracting the value of how much physical capital is worn out or reduced in value because of aging over the course of a year. The process by which capital ages and loses value is called depreciation. The NNP can be further subdivided into national income, which includes all income to businesses and individuals, and personal income, which includes only income to people. Nominal and real value. Nominal value, an economic statistic measured in using actual market prices, i.e. nominal values are just not adjusted for inflation. Contrast that with real value. Real value, an economic statistic measured after it has been adjusted for inflation, contrasted with nominal value. Comparing nominal and real GDP. If an unwary analyst compared nominal GDP in 1960 to nominal GDP in 2010, it might appear that national output had risen by a factor of nearly 27 over this time. This conclusion comes from the simple growth rate formula, or percentage change formula. Final GDP minus initial GDP over initial GDP, and that's the growth of nominal GDP. This conclusion, though, would be highly misleading. Recall that nominal GDP is defined as the quantity of every final good or service produced multiplied by the price at which it was sold, summed up for all goods and services. In other words, nominal GDP is the value of output produced. Nominal value of output equals price times quantity of output. We'll call this the real to nominal formula. Simple growth rate formula. The growth rate or percentage change of any variable x over time is the value of x in the final period minus the value of x in the initial period divided by the value of x in the initial period. The real to nominal formula, the nominal value of some economic variable, e.g. GDP, is the price level times the real value of that economic variable. So here's an example. Let's say that there's price of apples, quantity of apples. You can multiply price times quantity to get the value. You'll see that in year one. We can do price of xylophones, quantity of xylophones, and do the same thing in year one, price times quantity to get the value. Do the same process for year two. Notice that prices are changing and quantity is changing. So nominal output is the value of what's produced, while real output is the quantity of what's produced. In the previous case, pounds of apples. If we produce more apples, we can say our real output has increased. Now suppose our apple economy from above produces two goods, apples and xylophones. In year one, the value of apples produced was 1,000 and the value of xylophones produced was 1,000, so nominal GDP adding those both up is 2,000. In year two, the value of apples produced was 1,200 and the value of xylophones produced was 1,800, so nominal GDP was 3,000. Thus, nominal GDP increased by 1,000, the increase. That would have been the 3,000 minus the 2,000, and put all of that over the year one nominal GDP, which was 2,000, and you get a 15% increase. But what has happened to real GDP? Real output of apples has increased from 2,000 to 2,182 pounds. Real output of xylophones has increased from 100 to 150. How much has real output increased? Using these same numbers, we use price as a common denominator to add quantities of apples and xylophones together. We can choose the prices from any year as long as we use them with each year's quantities. So year one, real GDP, price of apples in year one times quantity of apples in year one, plus price of xylophones in year one times quantity of xylophones in year one. And then year two real GDP, price of apples in year one times the quantity of apples in year two, plus price of xylophones in year one times the quantity of xylophones in year two. In other words, we compute real GDP in every year using the prices that existed in a single year, in this case year one. That's why real GDP is often described as being based on constant dollars or year one dollars. Plugging in the values from the table above yields real GDP of 0.5 times 2,000 plus 10 times 100, 2,000. Real GDP in year two, 0.5 times 2,000 plus 10 times 100 equals 2,000. So real GDP in year two, we get the same thing, 0.5 now times 2182. We're using the different amounts of quantities of apples and xylophones. We're going to get 2591. So in other words, real GDP increased by 591. And we put that over the 2,000 and get a 29.6% GDP increase. And so that is significantly less than the nominal GDP increase of 50%. Converting nominal to real GDP. In order to see how much production has actually increased, we need to extract the effects of higher prices on nominal GDP so that we're left with real GDP, the increase in the quantity of goods and services produced. This can easily be done using the concept known as the GDP deflator. The GDP deflator is a price index measuring the average price of all goods and services included in the economy. Continuing along, the price level in 2010 was almost 6 times higher than in 1960. The deflator for 2010 was 110 versus a level of 19 in 1960. Clearly, much of the apparent growth in nominal GDP was due to inflation, not an actual change in the quantity of goods and services produced. In other words, not in real GDP. Recall that nominal GDP can rise for 2 reasons, an increase in output and/or an increase in prices. What is needed is to extract the increase in prices from nominal GDP so as to measure only changes in output. Nominal value of output equals price times quantity of output. Taking the GDP form of this equation, nominal GDP equals GDP deflator times real GDP. Divide both sides by the GDP deflator and you get real GDP equals nominal GDP divided by the GDP deflator. A price index, like the GDP deflator, is a 2-digit decimal number, like 1.00 or 0.85 or 1.25. Because some people have trouble working with decimals, when the price index is published, it has traditionally been multiplied by 100 to get integers like 185 or 125. When we deflate nominal figures to get real figures, by dividing the nominal by the price index, we also need to remember to divide the published price index by 100 to make the math work. So the formula becomes what we had before, multiplied by 100. Business cycle, the relatively short-term movement of the economy from recession to expansion. Depression, an especially lengthy and deep decline in output. Peak, during the business cycle, the highest point of output before a recession begins. Recession, a significant decline in national output, typically a minimum of 6 months. Trough, during the business cycle, the lowest point of output in a recession before a recovery begins. So here's what the phases look like: expansion, peak, recession, trough, recovery, expansion. Tracking real GDP over time, here's a figure that shows from 1900 to 2000 how real GDP has moved. It's important because it's highly correlated with other measures of economic activity like employment and unemployment. When real GDP rises, so does unemployment. The most significant human problem associated with recessions and depressions is that a slowdown in production means that firms need to lay off or fire some of the workers they have. The highest point of the economy before the recession begins is called the peak. Conversely, the lowest point of a recession before a recovery begins is called the trough. Thus, a recession lasts from peak to trough, and an economic upswing runs from trough to peak. The movement of the economy from peak to trough and trough to peak is called the business cycle. Other vocabulary: overheating, which means the economy is picking up speed, leading to increased inflation. Stagflation, which means the simultaneous occurrence of stagnant growth or recession and inflation. It's a situation where the inflation rate is high, the economic growth rate slows down, and unemployment is also high. GDP per capita, GDP divided by the population, often used as a measure of standard of living. Standard of living, all elements that are affecting people's happiness, whether these elements are obtained through market transactions or not. When economists talk about standard of living, they're referring to the average quantity and quality of goods and services that people in a country can afford to consume. Since real GDP measures the quantity of goods and services produced, it's common to use GDP per capita, that is, real GDP divided by population, as a measure of economic welfare or standard of living. Here's the formula: GDP per capita, take GDP divided by the population. The limitations. The level of GDP per capita clearly captures some of what we mean by the phrase standard of living. GDP includes spending on recreation and travel, however, it does not cover leisure time. While GDP includes what is spent on environmental protection, healthcare, and education, it does not include actual levels of environmental cleanliness, health, and learning. It includes production that is exchanged in the market, but does not cover production that is not exchanged in the market. Labor productivity and economic growth. Aggregate per capita production function is the aggregate production function expressed in per capita terms. It includes physical capital per person, human capital per person, and technology per person, and how they're transformed to be output measured as GDP per capita. The aggregate production function is the process whereby an economy as a whole turns economic input, such as human capital, physical capital, and technology, into output measured as GDP. Human capital, accumulated skills and education of workforce; innovation, putting advances in knowledge to use in a new product or service; invention, advances in knowledge; labor productivity, quantity of output produced per worker or per hour worked; production function, the process whereby a firm turns economic inputs like labor, machinery, and raw materials into outputs like goods and services used by consumers; technological change, a combination of invention, advances in knowledge, and innovation. Continuing on, the easiest way to understand labor productivity is to imagine a Canadian worker who can make 10 loaves of bread in an hour versus a US worker who in the same hour can make only 2 loaves of bread. In this fictional example, the Canadians are more productive. Being more productive essentially means you can do more in the same amount of time. This in turn frees up resources to be used elsewhere. Physical capital can affect productivity in 2 ways. 1, an increase in the quantity of physical capital, for example, more computers, and 2, an increase in the quality of physical capital. So, same number of computers, but they're faster. Another factor that determines labor productivity is technology. Technological change is a combination of invention, advances in knowledge, and innovation, which is putting that advance to use in a new product or service. Here we can look at the production function where you take these inputs, physical capital, human capital, technology. There's the production function and how it turns into GDP. Components of the aggregate production function, they determine those maximum quantities. Economic growth is illustrated by an increase in the production possibilities frontier, which we show in this figure 2. Shifting to the right, there's more that can be produced. The inner PPF corresponds to the maximum GDP obtainable given resources in 2010. The outer PPF shows the maximum GDP attainable given the resources available in 2010 when there's economic growth and it has shifted it outward. We can measure productivity and growth. Here's how it has changed over time. I'll let you guys read through that since this is getting long and I apologize. We can also show productivity with a bar chart, how it's changed over time. You can see there was a dip in the 71 to 90 period. Capital deepening. It's an increase by society in the average level of physical and or human capital per person. When society increases the level of capital per person, the result is called capital deepening. The idea of capital deepening can apply both to additional human capital per worker and to additional physical capital per worker. Here's how we can take a look at this. One way to measure it is to look at high school and college and see how things have changed over time. Again, I'll let you take a look at that since this is getting long. Growth accounting studies. Studies of the U.S. economy, 3 lessons have emerged from growth accounting studies. First, technology is typically the most important contributor to economic growth in the U.S. Second, while investment in physical capital is essential to growth in labor productivity and GDP per capita, building human capital is at least as important. A third lesson is that these 3 factors of human capital, physical capital, and technology work together. The power of sustained economic growth, compound growth rate, the rate of growth when multiplied by a base that includes past GDP growth. We have the rule of 72, which is an approximation to figure out doubling time. 72 is divided by the annual growth rate to obtain the approximate number of years it will take for an income or an economy to double. The Industrial Revolution, that was the widespread use of power-driven machinery and the economic and social changes that occurred in the first half of the 1800s. Modern economic growth has been the period of rapid growth from 1870 onward. We've seen this rapid and sustained growth. It's a relatively recent experience. Before the last 2 centuries, although rulers, nobles, and conquerors could afford some extravagances, and although economies rose above the subsistence level, the average person's standard of living had not changed much for centuries. Progressive, powerful economic and institutional changes started to have a significant effect in the late 18th and early 19th centuries, and the Industrial Revolution, that's when things culminated and started a new wave. A healthy climate for economic growth. You need contractual rights, the rights of individuals to enter into agreements with others regarding the use of their property, providing recourse through the legal system in the event of noncompliance. Rule of law, the process of enacting laws that protect individual and entity rights to use their property as they see fit. Laws must be clear, public, fair, and enforced, and applicable to all members of society. Special economic zone, area of a country usually with access to a port, where among other benefits the government does not tax trade. Continuing on, while physical and human capital deepen, better technology is important. Equally important to a nation's well-being is the climate or system within which these inputs are cultivated. Both the type of market economy and a legal system that governs and sustains property rights and contractual rights are important contributors to a healthy economic climate. A healthy economic climate usually involves some sort of market orientation at the microeconomic level or firm decision-making level. Markets that allow personal and business rewards and incentives for increasing human and physical capital encourage overall macroeconomic growth. Economic growth depends on many factors, key among them, rule of law, property rights, and contractual rights. We've talked about this before, that the laws must be clear and property rights have to be able to be enforced. The following examples highlight some important areas that governments around the world have chosen to invest in to facilitate capital deepening and technology. Education, savings and investments, infrastructure, special economic zones, scientific research. Here are the review questions, and these will also be in the PowerPoint slides that are in the files. I'll let you look at these on your own time since this has gotten so long. Here they are as well.